Hi class. We continue our study in chapter 6 talking about polynomial functions by moving into section 6.2, which is multiplying polynomial expressions and functions. Okay, so just to recall, I want to talk about what monomials, binomials, and trinomials mean. So first off, remember monomial means there's one non-zero term, so just something by itself. A binomial means there's two terms, so two terms for each of these. And a trinomial obviously means three. There's one, two, three terms, one, two, three terms in the expression. Okay, monomial one, binomial two, trinomial three terms. All right, so what I want to do in this section is talk about finding the product of two monomials. So something like this. I have the monomial 4x cubed y squared times minus 2x 6, or excuse me, y to the 6th power. So here I'm just in color coding what are the like, what's common, like the coefficients, the x variables, the y variables. So I'm just going to rearrange them. So when I multiply them, they're together. So 4 times minus 2 obviously gives me minus 8. Recall your rules of exponents. X to the third times x gets me x to the fourth. And y squared times y to the 6th, 2 plus 6 gets me y to the 8th. All right, just as a warning, remember that when you see a parentheses like this, it's a product. Okay, so this does not mean take this and subtract this. Okay, so whenever you see the parentheses here, it's to multiply. All right, so when you multiply two polynomials, multiply each term in the first polynomial by each term in the second polynomial, then combine like terms. So this is if it's more than just a monomial. So what I want to do here for each of these is I want to find the product of these two binomials. Okay, so I want to find x plus 4 times x plus 8. Okay, so what you're going to do is you're going to take the x and you're going to multiply it by the x, then you're going to multiply it by the 8. See there. Then you're going to take the 4 and you're going to multiply it by the x. Then you're going to take the 4 and multiply by the 8. Well, when I do that, x times x gets me x squared, 8x, 4x, and 4 times 8 get 32. Now what you have to do then next is combine like terms, and you'll notice here the middle terms, 8x plus 4x are the same, and they combine to 12x. Same deal here. So we have 5p minus 6w times 3p plus 2w. Multiply the 5p times the 3p, 5p times the 2w, and then don't forget this negative is attached, so minus 6w times 3p minus 6w times 2w. Well, multiplying here, I have 15p squared. This becomes 10pw. It's minus 6 minus 3 minus 18, and then a p, then w, and this is just minus 12w squared. Notice in the middle here, these are like terms because pw, pw. So 10 minus 18 gets me minus 8. So this just becomes 15p squared minus 8pw minus 12w squared. We got it. It's a little bit harder when you have a binomial times a trinomial. So again, it's just the same procedure. Take the 2x, multiply it, watch my mouse arrow, by everything, then take the y and multiply it by everything. You can see I've just done that in the next expression. I'd encourage you to pause the video here and see if you can simplify this expression on your own. I'll give you a second to pause it and try it just to see what you get, and then I'll show you what I get. Okay, so if you pause the video and then simplify, you're going to get the following, something like this. Well, then what you need to do next is combine like terms. Like you need to recognize this and this are like terms, this are like terms. So just combine those, rearrange them so they're adjacent. And this will simplify very simply to the following right here. All right, let's do another one. Let's do a crazy one. Let's do a trinomial times a trinomial. So again, take the first term, multiply it by everything. And take the second term, multiply it by everything. And take the third term and multiply it by everything. So I do this and I have this crazy expression here. So now I just have to clean this up, like x squared times x squared gets me x to the fourth. X squared times x gets me x cubed. X squared times minus 5 gets me minus 5x squared, and then so on. You can go through and you would get this crazy mess of an expression. What you then have to do is put the like terms next to each other. So in blue and red and green, you can see them there. then finally just simplify like this. So it's just a lot of algebra, and it's very easy to make a mistake if you don't, do it as I've written and take your time. Take your time is the most important part. All right, so let's talk about squaring a binomial. So if you have a plus b squared, that's equal to a squared plus 2ab plus b squared. And then a minus b squared is equal to a squared minus 2ab plus b squared. So in other words, the square of a binomial equals the first term squared plus or minus, depends, twice the product of the other two terms plus the second term squared. Always, always. All right, so let's simplify each of these expressions. So x plus 7 squared, and then 5t minus 4w squared, and then 3r squared plus 2y squared squared. Okay, so the same deal for this one right here. I'm going to take x and substitute it in for a and 7 in for b. And when you do that, you'll see that it just simplifies into this very, very quickly by following this formula. Or you could recognize that x plus 7 squared is equal to this. And you can do the same method I've talked about in the previous slides on how to multiply this out, and you'll get the same thing. Okay, so generally I actually think this is a little bit easier than following this formula, but you could do whatever you prefer. You could do the same thing for the subtraction one here, just by plugging 5t in for A and 4w in for B, and you'll see it simplifies into that. Or you can do the same thing as I did before, recognize that this quantity squared is itself times itself, distribute, and you get the same thing again. This crazy one here, same procedure, 3r squared for A, 2y squared in for B. You get the following. And you can verify this by going through and doing the multiplying 3r squared plus 2y squared times 3r squared plus 2y squared, and you will get the same exact thing. All right, a perfect square trinomial is a trinomial equivalent to the square of a binomial. So something like this. And I want to talk about the product of conjugates here. So a conjugate, if you have a plus b, its conjugate is a minus b. Anyways, if you go a plus b times a minus b, this will always, always, always equal a squared minus b squared. So in other words, the product of two binomial conjugates is the difference of the square of the first term and the square of the second term. So this formula I think is very easy to follow. You're always going to do this as a squared minus b squared. All right, so let's do some crazy problems here. All four of these problems here, excuse me. All right, so this one, this one, this one, and this one. All right, so let's do the first one, x plus 6 times x minus 6. Well, my a term is x, because it's the same here, so that's just x squared. And then it's always going to be minus. My second term is 6, so minus 6 squared. This will always be x squared minus 36. For the second one here, my a value is 3p. My b value is 8q. So it's 3p squared, and then in parentheses 8q squared. Don't forget you have to square the 3 and the 8 here, and this will be 9p squared minus 64q squared. Going forward, this one you can see the following. The a terms are the same, 4m squared, so it's going to be 4m squared. And then the 7rt is the b, so minus 7rt squared. And you're just going to get 16m to the fourth minus 49r squared t squared. All right, this crazy mess here, what you'll want to do is figure out what this is first, x plus 3 times x minus 3. Okay, when you do that, you're going to get a squared, which is x squared, minus 3 squared, which is 9. And then again, I have the difference of a minus b times a plus b. So it's just going to be x squared squared minus 9 squared, excuse me, which ends up just being x to the fourth minus 81. Pardon me. Excuse me again. Allergy season. Okay. let's go and take this and talk about writing a quadratic in standard form. So I have f of x is equal to minus 3 times x minus 4 squared plus 8. Well, remember the standard form for a quadratic is ax squared plus bx plus c. So first I'm going to simplify this x minus 4 squared. So when I do that, you take this x minus 4 times x minus 4, you end up getting x squared minus 8x plus 16. Next, I'm going to distribute the negative 3 through. All right, when I do, I get the following. And then lastly, I'm just going to combine the constants, get that. And that is now in standard form for this quadratic function. You can verify this in your calculator if you wanted to see this, but they actually are, as I said, are equivalent statements. All right, so if f and g are function and x is in the domain of both functions, then we can perform what we call the product function. It's just like the sum and difference function before. So if I have f times g of x, that's just equal to the f of x times the g of x function. All right, so if I have these two equations, f of x is equal to 3x plus 7, and g of x is equal to 5x minus 2. If I want to find an equation of the product function, I'm literally just going to take the two functions and multiply them together. When I do this, I'm going to get 3x times 5x gives me 15x squared. 3x times minus 2 is minus 6x. 7 times 5x gets me 35x. 7 times minus 2 is minus 14. You combine the middle here, and you get 15x squared plus 29x minus 14. Now if I want to find f times g of 2, well, if I know what the function is, I'm just going to straight up plug 2 into that. And when you plug 2 into that algebraic mess there, you get 15 times 2 squared plus 29 times 2 minus 14. And that, when you plug it in your calculator, ends up just being 104. All right, now let's talk about something called the composite function. All right, so if I have f of x is equal to 3x plus 7, and g of x is equal to 7x minus 2, I want to find the equation of a composite function. Now it looks like FOG looks like fog, but this open circle here means composition. And what f composition of g of x is you take your f function, and when the input you plug in, you literally plug in g of x. So it's f of, what is g of x? 5x minus 2. So now in the f function, wherever you see the input x, you're going to plug in 5x minus 2. So it's 3 times the input. Well, the input is 5x minus 2 plus 7. So I'm going to distribute the 3, and it will end up being simplifying just to 15x plus 1. So next, if I want to find the f composition of g of 2, well, I'm literally just going to plug 2 into that function I just found, and you get 2 squared is 4. 4 times 15 is actually 60, so this is a little bit of an error. This should be 61 here. They forgive the error here in not squaring the 2. All right, let's end on a practical example. Okay, so the annual cost in thousands of dollars per inmate, which we'll denote as C of T, in New York City prisons, can be modeled by this cost function. C of T is equal to 4.8T plus 77, where T is the number of years since 2010. Okay, so the average number of inmates in New York City prisons, again in the thousands, which we'll call N of T, can be modeled by the function N of T is equal to 0.42T plus 13.1. This is where T is the number of years since 2010. Okay, so I have a cost function, and I have a function that tells me the number of inmates. So this is the cost per inmate in thousands of dollars. This is the number of inmates in the thousands of inmates. All right, so here's the actual data from it from 2010 to 2014. You can see that the cost per inmate is going way up, but a positive thing, the number of inmates are going down, which is good too. This is bad, cost is going up, but number of inmates are going down. All right, so I want to do 4 things. Check that the model fit the data well, find an equation for the product function, perform a unit analysis on the expression, find find c times n of 11. What does it mean in this situation? And then use a graphing calculator to determine whether the function c times n is increasing, decreasing, or neither for values of t between 8 and 11. And what does the result mean in this situation? And explain how that could be possible even if the cost per inmate continues to increase by approximately the same rate. All right. Well, so if you plug in the two equations into their corresponding data, you can see that this is the cost per inmate is going up. It fits the data well. These are the number of inmates. It's going down. Okay, so that's good. Okay, that line also fits the data well. All right, let's find the c times n of t. Well, this is just multiplying the two functions. There should be a t there. Also forgive the error there. So when I multiply through, I get the following. So it ends up being minus 2.016 t squared plus 30.54 t plus 1008.7. Okay, the unit analysis of this, you have to be careful. It's thousands of dollars times thousands of inmates. So 1,000 times 1,000 gets you a million. So the units of expression here are actually in millions of dollars. So when I get this answer, the answer is going to be in terms of million. Okay, what does c times n of 11 is? Well, if you plug 11 in here, okay, and you end up simplifying, you end up getting 1,101. So this actually tells us the total cost of New York City prisons because it's cost per inmate times the number of inmates. Okay, great. So this means the total cost in New York City prisons will be about 1,101 million, which ends up being 1.101 million in 2021, according to this model, which is crazy. So that means that New York City is going to be spending over $1 billion on its prisons in 2021. Okay, to graph the model, set the window as shown for values of t between 8 and 11. All right, so what we're doing is we're plugging in, going back, this equation into our calculator. And you see this is what the graph looks like from 2018 to 2021. Okay, so this here is saying that the function, the total cost is actually decreasing, which is great. The reason that this can happen is although costs are rising, right, the number of inmates are falling at a greater percentage than the cost increases, percent increase of the cost. So while costs are rising, New York City is doing a good job of maybe looking for other avenues for people instead of sending them to prison. And we're seeing that the total cost is actually falling.